Hello, and welcome to today's lesson, Algebra Skills and Geometry Foundations, Lesson 1. This is going to give us all of our basic terms and definitions that we'll need to use and work through the entire semester. Okay, so our goals for the lesson. By the end of this lesson, you'll be able to describe, draw, and provide proper notation for the following objects: points, line segments, lines, rays, planes, angles, collinear points, and coplanar points. Okay, recognize and label congruent line segments. Okay, so every day that we go through here, okay, we'll start with these essential learning goals. This is the goal at the end of the lesson when you're going to the homework, what you should be able to know and do. Okay, so we have some terms that are technically undefined. We have to give them a definition so we can work with them in geometry, but we can always, in some cases, have an alternate definition to a point, and you would see that when you get to a college algebra class that looks at, our college geometry class, that looks at things in a little bit of a different point of view. Okay, first term is a point. Okay, it's the most basic building block we have in geometry. Okay, we need a point as a specific place in space. Okay, it's important to know that it's not a thing, but it's a place. We indicate the position of a point by placing a dot with a pencil. Okay, but we have to remember that a point has no width, no thickness to it based on definition. Okay, but it is a spot in space. Okay, our next term that we have is a line. Okay, a line segment, okay, is a continuous piece, okay, and it's just a connection or a collection of many points. Okay, has infinite length but no thickness. So we have to remember that a line does technically go on forever, and that's why lines are always designated with the arrows on either side. Okay, so this is line AB. If we put another point in there, we could use that third point C. We could name it AC, BC. As long as the points are on the line, we can use any of the points to name it. Okay, notice when we're naming, okay, the important part is always showing that it is a line segment with the arrows on the pieces of that naming. Okay, our term 3 is a plane. Okay, when we think about a plane, what we have to remember it's like the floor of your room, the floor of the classroom here. Okay, the only difference is, just like a line, a plane extends forever. Okay, so we have to think about the fact that it's an infinitely large piece, and that's why these are undefined terms. They're not something that can technically happen in reality, but in our situation, we need to define the shape. So you think about a tabletop is like a plane. The only problem with the tabletop is it has thickness and it's limited in size, where the plane does technically go on forever in all directions. Okay, now, when we look at defined terms, okay, we have some terms that can be combined with each other. Okay, we're using undefined terms that we have: points, lines, planes. Okay, we're using those terms that we have to make some definitions for our next terms that we have coming up. Okay, we're using that, and it's kind of like a definition. You never want to use a word in the definition of a word. So we can't say that a dog is blah, 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 a dog. We have to always have something that we build definitions based off of. That's why we have the undefined terms that are the building blocks for everything that we use in geometry. So our next term we have here is collinear. Okay, when we talk about points that are collinear, collinear points are on the same line. Excuse me. So we have points A, B, and C. They are all on the same line, and we can use any two of the three to name the line. So this could be line AB, remember the arrows. It could be line BC. Okay, direction doesn't matter. We could name it CA. So we can name this line in any of about 6 different ways. We've got 3 options there. We could come up with 3 more options. CB, we could go AC. We could work our way through and find all of those different pieces. Okay, now our next term is coplanar. Okay, those are 3 or more points that lie in the same plane. So they're lying on the same surface, thinking about it like a tabletop. You know, we look at our image over here on the side. Any player in a game of tennis is coplanar. Okay, they are lying on the same plane. They're playing on the same surface. But anytime a ball is hit back and forth, we have to understand that that ball is not on the plane surface plane. Okay, so we've got the players on the surface, which would be coplanar. Okay, the ball exists in another plane, a higher level. Okay, so it wouldn't be coplanar with the individuals that are playing the game. Our next term that we have to define is line segment. Okay, a line segment does have a starting and ending point, very different than the line itself. Okay, so when we talk about a line segment, okay, a line segment is defined by the 2 points that start and finish the segment. It's actually something that we can measure, okay, and that's an important piece. So notice the way that we designate a line segment. We use the exact same notation as far as letters, okay, but a line by itself has the arrows. A line segment does not have the arrows, and that tells us that it's a defined, measured distance between A and B. Okay, so now, it's always important to pay attention to the details. Okay, so if we're looking at the line segment AB, okay, which we would write like such, okay, the line segment is an object, okay, it's a tangible thing. We can measure it, and then notice when we're talking about the measurement, there is no additional feature with the AB. It doesn't have the line on the top. It doesn't have the segment notation. So we have to make sure that we're using the proper notation in any situation. If you're talking about the line that goes on to infinity in both directions, we would need the arrows. If we're talking about the segment, we would need the defined line, okay, start and finish, no arrows. And if we're actually talking about a length of a segment, okay, there is no notation on top of it, and that's where we would have the equal to 5. Okay, our next piece is congruent segments. Okay, congruent segments are 2 segments that are the same length. Okay, they're not necessarily the same segment, because here we have segment AB, okay, designating it with the truncated line, no arrows, and we have our segment CD, okay, same notation. Since they are the same length, we would put a tick mark on those segments to designate that they are the same length. Okay, if they're congruent segments, okay, when we're talking about objects, we want to talk about congruence. Okay, so a line segment is an object, so we use our congruent symbol. Okay, we're not saying that they're equal to each other. That would mean that they're the same segment. So if we wanted to make an equality statement here, we would have, and we can't use CD, if we want to make an equality statement, we could say AB is equal to AB, segment AB is equal to segment BA. We could do an equality statement with the same thing, but as soon as we're talking about two different objects, if we're talking about the segments, okay, we have to use the congruent symbol, okay, which is that additional piece on the equal sign. Okay, one of our last pieces we have here is the midpoint. Okay, the midpoint cuts any segment into two equal parts. We can designate those parts, once again, like we saw before, with tick marks. Okay, and those tick marks tell us that the two segments that are congruent here are segment TU is congruent to segment UV. Okay, now, if we want to talk about the length of the segments, okay, then we would take the notation off of the TU and we would say the length TU equals the length UV. Okay, so we have to make sure that we're dealing with the notation properly, okay, being careful with those small pieces. Our next term that we have is a ray. Okay, a ray has a specific starting point and then a direction that it goes in. Okay, so when we look at these two rays, they both start with A and they go in the direction of B. Now, I could put another point out here as well, and this could be ray AC also. Okay, but whenever we're naming the ray, just like a segment, we need the endpoint. Endpoint has to be listed first, and then the ray goes in the direction of another point that's somewhere on that line. So when we're looking at this situation, the very first thing that we have to think about whenever we're naming rays is what is the starting point. Okay, so we have to start with B in naming these ray values and know that they're going to go in a certain direction. This one can go from B in the direction of A. And remember, just like a line, a ray goes off to infinity in that one direction. So we could also name this one BC. Okay? Same starting point, same direction. Okay, and that's what's important with rays. The starting point of the ray and the direction that it goes in. Okay, the midpoint is a bisector. We talked a little bit about that in the last slide. Remember, it cuts it into two equal pieces. A ray can bisect an angle, so now we're talking about degree measurements, and we'll get more into that in later lessons. Okay, we designate that the angles are equal to each other with tick mark designations. Okay, we'll come back to angles more, like I said, in some later lessons. Okay, now, making sure, always being careful of proper notation, and that's something that we have to get used to in geometry. So when we're talking about MA and TH, okay, we can see based on the measurements, they're both the same length, but what we have to do is put the proper segment notation in and the proper length notation. So when we look at segment MA and TH, they're different segments, they're objects that are the same length. So what we need is, we need our congruence symbol when we're talking about segments, because they're not the same segment. When we're talking about their measurements, that is when we can say that they're equal to each other. So segments are congruent. Okay, so here's our segments. Okay, so the segments are congruent and the lengths are equal to each other. Okay, so those are, once again, small pieces that we have to be careful with, things that will help us as we move through our later lessons. Okay, so that is the end of lesson 1. Okay, we've got our Schoology homework to work on for this topic, and have a good day.